Hello, everyone. So today we're going to look at a few more confidence intervals, and we're going to look at things in RStudio. How do you do a confidence interval using RStudio? Since that's, usually you're going to have a data set that's probably in a spreadsheet, so it makes sense to use that instead of doing things by hand. All right. So we're just going to look at a few cases of this. I don't know why I'm not presenting. All right, there we go. All right, so we're going to learn how to we're going to use RStudio to calculate a confidence interval for mu and look at what needs to happen when the sample size is small. And then we're going to review real quickly confidence intervals for differences in two means and see how to use RStudio for that, and especially when we have small samples. Okay, so first of all, these would be, I believe, rows 1 and 3 of that document that has a table on it of all your different confidence interval estimates, right? So for rows 1 and 3, and you could write this right in there, right? Right in those rows. If you're going to calculate a confidence interval estimate for the mean, for a population mean, you're going to use this RStudio script. T.test, this is the variable name, conf level equals 0.95 or whatever confidence level you need. Really easy script. All right, you can have that right on that sheet, and then whenever you need to use it, it'll be there. And we're going to use it, we'll be using it a lot, this kind of thing. Warning, RStudio doesn't know if you have a large sample or a small sample, but you know that those are a little different, right? There's some different rules for small samples. Indeed, if the sample is smaller than 30, we need to make sure it appears to have come from a normal distribution with no outliers. Remember, the central limit theorem doesn't apply in small sample cases. So you don't necessarily get a normal distribution. Remember, it ended up using a t, like we used a t table when we did it by hand. So you need to know, and that's only if the sample appears to be coming from a normal distribution. So if the sample is small, first do a quick box plot to check for outliers. All right, and remember, in RStudio, the script is box plot x, like whatever the variable name is. And I just want you to remind you that in RStudio, outliers will show up as dots, these little circles. Okay, actually the box plots are usually vertical, but the outliers still show up as dots. And if there are outliers, then it might not be a normal distribution. So you cannot use these methods. And in fact, we won't go through. There's other alternative methods in statistics that we're not going to cover in this class. All right. So your first prep work activity. In Google Drive, I want you to go open the file datasets and R information, which was shared with you. Go to shared with me and type the name of the file, or type my name, peg.hart, and it should pop up. Okay, you've been in this file before. Now upload the 2020 class data file into RStudio. All right, and then make sure you use the attach data file name script to assign all the variable names, by the way. Okay, so you're going to kind of go through the stuff that we did the very first day we went through RStudio. If you don't remember how to do this, you have a handout. It's called Summaries with Google Sheets and R, explaining all of it, how to upload into RStudio. And I believe all of you were able to do this in class. If you don't have that document, it can be found in the same file that you were just in. Okay, so go find that document and go through those steps and upload it. I'm going to expect when you come to class that you have this data file already uploaded. So I'll kind of walk around and make sure you have it. If you have trouble, just pop into office hours sometime. All right, so that's one of your jobs, is to get stuff uploaded. All right, go review how to upload a file. We'll be using lots of different files. All right, so I'm going to assume that you have that uploaded. If not, pause the video and go do that. In this example, we're going to get a 95% confidence interval for the average number of broken bones in that 2020 class. All right, so by the way, a lot of times in RStudio, I'll just type like broken bones, the name of the variable just to see if RStudio is really reading the variable correctly, if you type that, it should just give you a list, like all of a sudden return a list of all the different numbers of broken bones. It'll be like 3, 0, 3, 1, blah, blah, blah. All right. It's a really good check to make sure that RStudio is reading your variable. You can view the data up in that upper pane. You can scroll through it and you can see that there's only 18 entries, n equals 18. That's small. So we're going to check for normality with a box plot. And darn it, there's one outlier. So when you do the box plot on broken bones, you'll see an outlier. Somebody has had 6 broken bones. We cannot use this method to estimate the mean. So we would not be able to estimate the average number of broken bones for this data set. However, if we want to estimate a confidence interval for average height, okay, maybe that will work. By the way, here's something else. I'm just trying to go through some things that'll happen when you use RStudio. And when you use technology, there's always like weird quirks, right? When I typed HT in RStudio, for whatever reason, I think it's because I had another data set that had recently been opened that also had height in it. It didn't, but it wouldn't recognize height for me. So I had to assign the variable in a different way, like in the way that we did in that other lesson, okay? So this is a different way of assigning that variable. This is what I want to call it, HT. And then this is equals this. What this is doing is it's saying, okay, look at the 2020 class data. All right, so I start typing 2020 and this will pop up and I just click on it. And then I type double brackets and the name of the variable between quotation marks that shows up in this file. It says, this is what I want to call it. And when I did that, then all of a sudden HT showed up the way I wanted. The heights from that data set, the 18 heights showed up. So just showing you, sometimes there's weird things that you have to do, okay? But there's still only 18 entries, and that's small. Check for normality with the box plot again. Does it appear normal? So try the box plot and see if it's normal. All right, if it's normal, then we could use this script, this t-test script, to find the confidence interval. Okay, so I did t-test, ht, comma, conf level 99.99, and all of this crap comes up after you return, right? There's a lot of stuff that comes up. We'll be using a lot of it, but not yet. For now, the only part we're using is this part that says confidence interval. All right, and that does the addition and subtraction. We just need to interpret it. We're 99% confident that the average math engineering student, this was my 2020 class, is between 65.8 and 73.31 inches tall. And we're going to go with 2 significant digits. And I bet that's still true about the class. I bet that is true about math and engineering students. Probably does capture your mean. All right. So prep activity 2, I want you to use in RStudio, calculate a confidence interval estimate and give an interpretation for my husband, who's not a statistician, if the method is appropriate. So you might have to do a box plot for each before you use the t-test script to calculate the confidence intervals, okay? So do these. So pause the video and do these 3 problems. It should not take you long at all. I mean, you'll have to write an interpretation, and you can just do it on paper. Just do the interpretations on paper. All right, so drag it out, do the interval, and then write down what you get, okay, and do the interpretation. So pause the video. Okay, so what if we want to do confidence intervals for the difference between 2 means? Like, is there a difference in average GPA between athletes and non-athletes? That's actually an interesting question, right? We'll be able to answer that, okay? So you don't do 2 confidence intervals and compare like their overlap or anything, okay? Instead, you do this, you guys already know this, you do this difference, right? This subtraction of the means. And remember, we went through this logic in class. Like if the interval is always positive, then the first one's always bigger. If the interval is always negative, then the second one's always bigger. And if it goes from a negative to a positive, that means one of them might be like, they might be equal. And it means we're not sure if there's a difference. So just, go through, we went through that in class last time. Okay, so let's talk about the three main cases for confidence intervals for the difference between two means. We're going to do these first two right now. I think this is row 4, which is 5.4 of your table, and this is row 6, which is 5.6, row 6 of your table. This is for large samples, this is for small samples. Notice for small samples, you need to check box plots, right? Check a box plot of the variable, okay? But here's what you're gonna do. You'll see it's almost exactly the same script. It's t-test, and now there's this other variable, x tilde y. What this other variable is, it's a categorical variable, which is like creating the two different samples, okay? So in either case, right, large or small, okay, you will have a numerical variable x and then a categorical variable y that's creating two samples that you want to compare. All right, so let's see an example of this. We'll be doing this in class too, real quickly, but it's super easy to do once you have your data set in there. Okay, so let's suppose we wish to estimate with 99% confidence the difference in the mean height between students who play varsity sports and those who don't. Notice varsity, that variable is a yes-no variable. So it's perfectly suited for dividing our sample into two samples. It's almost like we have two samples, right? Okay, so first we got to check the box plot for normality. And when I did that, I just did the box plot for for height. And it's totally fine. Okay, there's no outliers. It actually looks super symmetric. All right, so we're good to go. So I did t-test height tilde varsity, right? That's a categorical variable, just yes and no, and then conf level equals 0.99. And when I get the whole thing to pop up, but the only part we needed was this, negative 5.45 to 9.25. So actually, there may be no difference in the average height between students who play varsity sports and those who don't. Maybe that's surprising to you. I don't know if it is or not. All right. So when you come to class next time, I want you to open RStudio and upload this same file, this 2020 class data file. It's a pretty fun little file, has some interesting results. Will you be using it in one other data set this week in class? In addition, we'll do a few more Google Sheets calculations on some other things. Let me know immediately if you need me to bring an extra machine to class for you. I'm happy to do that, but as you know, my office is all the way across campus, so if I leave I need to know in advance to bring the machine. In addition, you'll have homework problems using RStudio due next week, so you want to be on top of this so that you kind of know how to do it. Now, I don't think you'll find it hard, but you will need to practice it in class. All right, so if you don't bring a computer, you're sunk. Okay, so make sure you bring a computer this week. Actually, from now on. All right, so bring a computer every day. You guys know if you don't have one or don't have one that's adequate for doing these things, you can get one from the help desk. No problem. They'll get it to you like immediately. All right, that's all I have for you. Thanks a lot. Have a good evening, morning, whatever time it is. Bye.